where else do you see agents being applied in this whole component management and intelligence layer process?
I think obviously with every industry, we will see a number of agentic workflows coming in there. In the hardware world, it's slightly difficult and different. The way I think, and we kind of talk about that in the team, is that the future of hardware design in general and building isn't just about working faster, which generally agents would do. It's about making better decisions at the right time and faster, right? It's making better decisions because yes, you can work faster, but it won't help in there. Software can ship very fast, but hardware has to ship right.
Hello, everyone. Welcome to the Altium OnTrack podcast. I'm your host, Zach Peterson. Today, we're talking with Avinash Harsh, co-founder of Wizerr AI. Avinash is new on the podcast, and his company is an AI platform for electronic supply chain management and design intelligence, and I'm very happy to be talking with him today. Avi, thank you so much for being here.
Thanks for having me, Zach.
Yeah, absolutely. So as I mentioned, you are a new guest, and normally when new guests come on, I love to hear about their backgrounds, how they got started in electronics, and how you got started with your company. So if you could, please indulge us.
Well, Zach, mine is a pretty mixed one. I come from electronics engineer as a training, software builder as a career, and have always worked in hardware and manufacturing, initially by selection and then by choice because I just loved it so much. And started my career with Siemens and NEC Japan, and then worked through in the Bay Area with an LTX electronics manufacturing company. Later, I built a mobile API platform company that was also focused on manufacturing teams to really bring siloed data outside for their customers, employees, and everyone else. And I learned a lot while working with this. We got acquired by a public company, and I got a chance to work with many companies, many large manufacturing companies on that. And one thing I've always admired is about how software is so different than hardware realities that we build in, right? And coming from the software lens, I've always seen that you have things that you can catch early, you can flag risks early, and that's where I think we miss a lot of these things in hardware. And that was the intent of Wizerr initially to start with as well.
You talked about catching things early. I feel like those of us who do, design education and probably, design services, we're always trying to talk about that and trying to do that. But it's where does the rubber meet the road, and how do you actually do that and hopefully do it in a more automated way? I think different companies have different processes that they try and implement, but it's always manual. It's always looking through the data sheet. One guy tries to be more innovative than the next, but at the end of the day, there's always something that gets missed, and you don't notice it until you're testing a prototype, and who knows how much you might have to spend to do a respin.
That's right. That's absolutely right. And that's the absolute problem that we all face. And again, looking at from a software lens at times, right? You can catch issues early. You can reason through things that are going on. You can also move with some confidence. And you come back to the hardware world. We are building some of the most complex products in on earth, from drones to pacemakers to humanoids, systems with thousands of components, which has global supply chains and things like those. Yet many of these decisions, if you think about it, right, they are taken using PDFs and depending on how much time an engineer would have. And then you are looking at siloed tools that also don't talk to each other. And I think that's the genesis of some of these problems that we have been seeing. And bringing the software lens is very important because you see some parallels onto that piece. But you know it very well, Zach. Once a hardware design is locked, right? Once you lock the hardware design, you are committing to real components, real suppliers, real lead times, and everything. So your mistakes don't get patched like a software team could do, right? They get redesigned, they get requalified, they got recalled. So it's a challenging one to really bring in. That's where we really wanted to focus on. So with Wizerr, like what we have done is we have built what we call an AI native intelligence layer for electronic components. Right? So teams can make better decisions faster, early in the design phase to even taking it to the procurement level. So it kind of understands components at the core rather than a parametric level only.
So when as a software person, when you say an intelligence layer for electronic components, I think for the hardware people, that's probably not very tangible. So if you could go a little deeper on that. What does it mean to have an intelligence layer for electronic components? And at the end of the day, you're trying to get information to the designer, right? So what kind of information can they get out of that?
Yeah, I mean, if you think about it, parametric systems have been around forever. They have done a fantastic job. Engineers can actually shortlist based on voltage, tolerances, things like those, and then work through them to be able to make decisions, right? I'm talking about from the design level itself. What if there was an autonomous way to really say what you are designing right now, the components that you're using, and the E-bomb is not even, engineering bomb is not even finalized? Can I suggest you something autonomously that is functionally equivalent and has some trade-offs built in? It's not the search, it's the intent of the design that is actually missing when you search something from, they're disconnected. So we are able to get that because now when you understand the component intelligence, and let me just go deeper onto the component intelligence layer itself, right? Today, parametric tables have the first two or three, data sheet things that you are already in there. But when we are looking at graphs, when we are looking at pin diagrams, when we are looking at thousands of pages of a data sheet at scale with millions of those, that's what the component intelligence layer does today, right? We are able to understand it, how an engineer would think about it. And that's when you are now making decisions slightly autonomous by saying, when I'm using this, can I actually have some way to figure out what's available out there which is functionally equivalent, understands my design a little bit, and then gives me some options to really work through. Right? That's not possible today unless an engineer spends a ton of time going through every data sheet. And on top of it, you have no idea at that point what is the supply intelligence on that procurement level information, which is generally other tools that engineering teams struggle to have that combined in. So this component intelligence actually brings in both together to be able to make some decisions early in the design phase. We know that almost 75 to 80% of that cost that we are talking about is locked at the design phase. The rest is, yes, you are now managing it. What if we can actually change that? Is where we are heading on.
So I'm hearing here an interesting gap between design intent and then where you actually create the design, right? Because you're talking about parametric search, right? If I just, let's say, write out a generic resistor description, right? Let's say, right, into DigiKey, Mauser, Octopart, Google, whatever, right? It's going to give me some parts, right? But I then have to go through each one of those individually and then make sure that it actually fits with the design intent, right? Unless maybe they put like the AEC, 200 whatever it is,
That's right.
qualification or whatever
That's
right
right.
there in the description and I just get lucky, right?
That's right.
Otherwise you would need to do that manually. It sounds like now you can have an intelligence layer that's actually able to take the design intent as context and then
That's
help you go through and narrow down to those components.
That's right. Design intent is very rich and but also very human in a way, right? An engineer knows why they chose a component, right? They know this fits my design. Yes, I see there is an alternate that is out there that I know of. There's some life cycle risk if they have that intelligence on that. And sometimes it's a qualification history that they might have saying, I know that this thing works reliably over here. But once that decision turns into a schematic or a bomb, for example, that whole intent actually becomes just a part number. If you think that's not carried forward, that's why the downstream teams, they don't see the intent that an engineer took. They are looking at supply availability. They are looking at pricing on that, and then it goes back and forth between these two. We can shrink that thing. We can shrink that uh, in a way that a shared intelligence is carried forward for the design intent, but also having both sides of it. That's why I think procurement questions engineering redesigns happen pretty late at times, right? So a lot of these things happen because that intent is not carried forward. So what I would say is the real gap isn't between tools or something. It's I think it's between the human reasoning and the static things that finally translate a part number kind of a thing on that. So in hardware, we don't really lose designs. We actually lose the intent as we move forward.
It's interesting you're saying that, right? Because the you lose intent as you move forward because, you know, for complex products and even products that have to maybe follow a lot of standards, have reliability standards, right? There's going to be like a requirements document that gets attached. And I didn't think about it consciously, but now that you say it, you lose the context moving forward. I feel like you just get this requirements document at the very beginning. Maybe you pull out 10 bullet points and then it gets lost somewhere on your hard drive and then you forget about it.
Yeah, and I want to add in when I say you lose intent in terms of current tooling is what I meant. So
I see.
what I meant was that yes, you have tooling for schematic design and everything. Engineer knows the intent. When it turns into a BOM, it's a part number that we are going after, right? So the tooling doesn't understand the intent of what you're doing to really suggest you alternates something based on the design intent, right? It's very different. So the intent is lost in terms of tooling, and an engineer versus another human being is saying, no, 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 that's not going to work because of this reason. So that intent doesn't get carried forward in terms of how the tooling works today in the electronics value chain. That's what I meant on that. So if you are able to carry that with some intelligence of the component itself as a full intelligence, and then carry the design intent, I think we can do wonders because we can shrink that cycle quite heavily onto that piece.
So where would a tool like this live in the design workflow? You mentioned, this is something that I think you intend to use more at the beginning of the design workflow to establish requirements and intent and constraints and that kind of thing. But I could see it probably living in multiple places in the design workflow, depending on what your internal process is or what your team composition is. What are your thoughts on that?
That's right. No, you hit it on that. Wizerr actually sits a layer below the traditional tools that we have in the electronics industry. At the core of it, Zach, we are building what we call a component intelligence layer. Now, this could be used by OEMs while designing to procuring, could be used by CMs because they are also working on that, could also be used by distributors and suppliers because component intelligence could be tapped in many ways for the various use cases. So we sit definitely below a layer below. On top of that intelligence, what we are opening are what we call the action layers. Like think of it as workflows that are very specific to certain areas that come right after somebody has thought of a full design up till sourcing. So, for example, to make better decisions while they are actually designing, saying which one is a better one for me to use. That intelligence today takes a lot of tedious time for engineering teams to really go what you just mentioned, surf through all these data sheets, make a decision, find something, run FFF analysis, and say, okay, give me a deep insight into that. Those things could be done by a Wizerr today at the engineering level. When it comes to procurement and supply chain, I believe it's giving them superpowers because instead of throwing back to engineering, say, hey, we couldn't find availability for these 10 or 20 components, they can actually use Wizerr to go deep and run a lot of things that engineers would otherwise spend time, which is not the best use of their time anyway on that. So, in a nutshell, building it like a component intelligence layer, and then opening some design to source workflows, which truly can be agentic because now you're looking into the component to a functional level rather than just on a parametric level.
Obviously, this all requires access to a lot of data, right? And of course, I'm curious, where are you getting all that data? Are you just pulling everything out of data sheets? Because there are other AI systems that essentially just focus on the data sheet.
So data sheets is, obviously is the core of many things over here, but there are many other things that you need to attach to bring the right trade-offs, right? So data sheets, absolutely. We partner with Octopart for multiple things, for example, in terms of pricing and things like those. But we have built a full system of intelligence. And the way I say that is collection of data is definitely one big element. But the most important, how do you understand that data in a machine readable format is what we have built with our engine. That's the patent pending thing that we have built. We call it ELX for lack of better words, but it's called electronic language and extraction engine. So with that, we are able to then understand at scale in a machine ready format on that piece. Yes, we partner with everyone who is in this industry has so many overlaps with different companies, but at the end of the day, the idea is to really build the hardware faster and with less design risks on that.
So if somebody had access to Wiser and all of these data and all this data, let's maybe come up with some examples of what folks can do, right? I think you alluded to one, which was on the procurement side, and I have one in mind with like test engineering. And let's maybe explore those. So on the test engineering side, one thing that sometimes happens in automotive, aerospace, those kinds of industries is they do a lot of component qualification, and it's not just MILPER for automotive standards. It's actually some kind of internal reliability standard. Like my favorite one is like hollow core components, right? Some capacitors you can't put them into orbit because the pressure differential will cause the component to explode.
That's right.
um, that's a really interesting one, but you won't find that in data sheets. That's something that only comes after some internal testing and people figure it out. Okay, we have to disqualify this part because of this reason. Is that the kind of context you could add into your component intelligence layer through Wiser?
Yes, very soon. Reliability and qualification is one of the top things. It's not there today because we release only when we are completely satisfied with the verification layer that we have built on top of it. So that's one of the things that you could potentially look at. Same with product change notifications. You could look at that while we have the right ones coming in. So the entire cycle that triggers if there's a product change notification that calls for a new data sheet to come in, right? That whole system is sort of is there, but it's still broken. They don't talk to each other on these things. So we do that, those kind of things. But to give you an example of what companies can do today, from component engineering to hardware engineering to procurement and sourcing teams, what they do today, on the at the base level, the product is open, so one can go and find deep functionally equivalent cross references, alternates, form fits, talk to them as if they are talking to multiple field application engineers from different companies. We give a reasoning behind it, and it's pretty sophisticated in terms of how the scoring happens to that. We give it a wiser score, so that then they can say, okay, why did you do that? And there is a reasoning and there is a citation and everything, so they can make a decision. Today, if it takes 8 to 10 hours to find a truly deep alternate which can work with the design, you can find it in 3 to 4 minutes on Wiser. Right? That's how we are looking at it. You can also run a full FFF analysis, for example, sends you mail. But I think the value really comes in right now, which is with the agentic bill of material that we launched very recently. That is, I think, that is something that we believe changes the way design engineers are working even before the engineering bomb is formed, or it's like just in works right now. They upload a full whatever they have in mind, a bomb on that. The system works with engineer grade precision to look at every part, suggesting them what is a technical merge possible out there to bring economies of scale. Technical merges, which is very difficult otherwise, unless you understand the component's functionality deep down. And then it works like a procurement insight on that to really bring your other aspects of it, whether it's available, whether it's what is the pricing. And then on top of it is a reasoning layer that actually says why we think these are the right ones and how much money you can save with these technical merges. So the idea is not to just bomb. There are a lot of bomb tools, which is great, we need. But once you understand to a component functional level, then you can come back with economies of scale, merging different part numbers, different supplier names, but functionally equivalent onto that piece.
So I see that almost as a portion of cost optimization, but without compromising on certain performance metrics.
That's right. And engineering wise, if you think about it, I mean, I care more. I come from an engineering background. I really care for things to work. And yes, cost is a thought, but it's an afterthought, right? How about we mix that and say, okay, there's a trade off, but you find something better. And that's the part that we assist a lot of these engineering teams on today.
I see. Yeah. I mean, in some industries, right? Again, going back to aerospace, right? There are infinite checkbooks that get pulled out. No one really cares about the part cost.
Yeah.
But I guess if in consumer electronics, right, this can be really critical because so much of the customer base is so price
Yeah.
sensitive.
And it's not just the cost part. Sometimes it's obsolescence. Sometimes so the trade-offs are based on many things in the aerospace industry. Yes, cost might not be a big factor, but obsolescence is, and
Yeah.
that's a challenge. So how do you really bring a trade-off early in the design level, and then carry it forward? The same intent is what we are looking at. So with this agentic bill of material, we are able to collapse like months of back and forth that goes between engineering, procurement, supplier discussions to a few minutes of, I would say, clarity in there. So that's a very powerful thing that we are seeing, which is a very recent launch that we did.
Very, very interesting. So, you're hitting all of the AI buzzwords here, right? Agentic, right? I was, I thought it would happen earlier in the podcast, but I think we got about halfway through the episode before agentics was mentioned. So, where else do you see agents being applied in this whole component management and intelligence layer process?
I think obviously with every industry, we will see a number of agentic workflows coming in there. In the hardware world, it's slightly difficult and different. The way I think, and we kind of talk about that in the team, is that the future of hardware design in general and building isn't just about working faster, which generally agents would do. It's about making better decisions at the right time and faster, right? It's making better decisions because yes, you can work faster, but it won't help in there. Software can ship very fast, but hardware has to ship right. And that's where we see that a lot of these agentic workflows will pinpoint on. We also want to be in that workflow itself. If you see watching designs, autonomous bomb optimizations, supply signals, flagging risk, suggesting alternates, all those places have a very good agentic autonomous functions possibility in there on that piece. If you have the intelligence of that.
Do you also see a role for Wizerr in like design review, right? For example, right, companies may work with like an external services bureau, right? Let's say, and of course, whatever the service bureau provides needs to go through some sort of internal review. Do you see your platform being useful for that as well?
We haven't done that yet, but what we can do is based on a particular, because the knowledge of components is to the functional level, what really could work with a basic schematic is doable. That means it's not a full design review, but a high level verification so that it will work with your design when you are choosing this component because you are connected to a few others in that particular schematic. We can do that. So yeah, we haven't done design reviews, and that's a great point that we could look at as well. So.
Yeah, because I see, you're thinking about a broader component intelligence layer as really touching all of these different areas where I see some other AI companies kind of operating, right? You have some folks that just focus on the design review side. You have some folks that focus just on the talk to data sheet side. And if I'm being honest, I haven't really seen a very good, alternate selection kind of workflow as well. But you're really touching all of it with this type of platform.
I think a lot of these companies can actually tap into the intelligence of the component itself because they have to do certain workflows. And that's how we are building Zach. I mean, we are not building a point solution here. We are building it like a layer which could be tapped in. As a matter of fact, it's built like a platform where people can actually build, teams can actually build on top of it. So they could use this to building their own agentic layers or apps or whatever they want to call it at that point.
Yeah, that's spoken like a true software development veteran when you say building a layer that other folks can tap into. Because, yeah, I do feel like a lot of the other AI solutions out there, aside from like the high level design synthesis kind of solutions, are really, like you said, point solutions. And this goes well beyond that.
Yeah, we believe that it's bigger than one company actually at this point because we hardware has a potential to turn itself into what software saw for years, the
Right.
intelligence that piece.
So something you just mentioned also, which I think may be interesting to a new generation of entrepreneurs and developers out there, is building on top of the component intelligence layer. What do you see as some possible applications that someone could implement?
I think a lot of these are internal applications by OEM engineers, for example, themselves. Obviously, new ideas from other people will also come in, but we see teams have their own internal tooling at times, and they want to use this intelligence to really feed into that tooling, right? Because they do certain dashboards or whatever they're working on. But I believe that insights coming out of other areas combined with component intelligence is a great way to really showcase whatever the use case is. Design review, for example, could be one of them.
We've been talking with over the past, I'd say, year and a half or 2 years. We've been talking with a lot of companies, right? A lot of them that are putting out new products are doing something with AI. Obviously, right? We've entered the AI age. So I see. I think there's going to be a big change in the overall design workflow, and it's going to somehow revolve around the incorporation of these new tools. I don't think the new AI tools are going to wholly replace the legacy software. I think there's going to be some
Absolutely.
bolt-ons, some add-ins, some integrations, and it's really going to change the developer workflow or the designer workflow. So how do you see the hardware development workflow changing over time?
As I said, I think it's the hardware obviously has multiple phases where every company has its foothold right now, right? You have design tools, you have sourcing tools, you have this. I would say at steps where decision making is needed, because it's hard to imagine that while you want to be like a software, it's hard to imagine where there are real components, real supply chains, real this. It's not bits, it's atoms, where you would be relying on many things can be done seamlessly with one flow. So I believe that there is a reason for everyone to believe that agentic workflows, right from design, which is happening already in your world, I know for sure, to how do you really think through it, and then how do you really source it, is going to change. But again, I would really emphasize that my thought is the future of hardware design is not to build faster only, which is going to happen, which is bound to happen. But how do you make faster decisions? Because that's a missing link right now. Once we have those ability to make very fast decisions, either by agentic workflows or by people, then it's going to. Today it's a very fragmented world. I mean, it's the most fragmented world you can think of, even from a supplier data sheet point of view to things that you really need to collate to make one single component decision on that piece. And for us, the focus has been for last 1.5 years. We have spent. It's a team which is multidisciplinary skills. We come from semiconductor to enterprise software to AI background, and so we have been focused on how do we really bring the intelligence into the system, the way engineers think with trade-offs and how what could be used further. And that's what's going to open up a lot of these things.
Well, speaking of fragmentation, there's one area. Well, let me back up. The PCB design companies and Altium definitely has been trying to eliminate the fragmentation for some time, and I think we've done a really good job so far of eliminating some fragmentation and siloing between electrical and mechanical. One area that I think AI will have a big impact, where there is still a lot of fragmentation, is electrical and firmware or application, right? Because so many devices out there need
Yeah,
firmware, but like go find a PCB design software application that has an IDE or any kind of link to an IDE. It doesn't exist, right?
that's right. That's right.
Do you think any of these kinds of tools and workflows will enable a de-siloing of those two areas in the future, and maybe start to bring more embedded and electrical people together? Sometimes they're the same person, right?
This is a beautiful point, Zach, by the way. And I just want to emphasize one more time thing that software has seen this intelligence grow over a period of time, processes and everything. Last 2 decades, it's hardware's turn now, and this is going to happen because companies like ours and companies there are other companies that are building into every segment, and it's this whole area will be patched up in a good way. What you just mentioned, software and hardware mix where the intersection happens, is a great growing area where there's so much innovation could happen today. And for that, you need the fundamental blocks though to be working. And I think LTM is working on a fundamental block of how the design is going to be expedited. And so are others who are working on other areas. So I think next year is going to be very interesting because the speed is not like in decades now, it's going to be in months. So we'll see a lot of that. We are pretty excited about what we can bring to the table with this intelligence and what kind of use cases we can open up as well on that.
So you mentioned one possible new feature on the roadmap in the future, which is reliability, right? Like internal or proprietary reliability data. What are some other features that you have on the roadmap, or that you think would might be valuable to the users?
I think from a roadmap perspective, we want to think of it as design aware at every step, whether it's a bomb optimization to anything, finding an alternate. So we want to truly make it design aware, not like okay, there's something in there. That's one piece that we are actively working on right now. Second roadmap item is be where the users are, right? In LTM, while they are working, they should be able to get that intelligence while they're working within LTM, for example. And same with the ERP systems where when they are looking at supplier, they should be able to do more rather than doing that. But most importantly, I think the idea is to really bring in this whole design intent carried from design to source workflows. That's what we are very focused on. And obviously, the component intelligence layer work is not done. It's still improving. We benchmark against ourselves. It's one of the best. We can read up to 125 pins, dense diagrams, and come back with things. But we keep improving on that. So that layer keeps improving more and more. And as more and more users use us, we see the way people are using it. So we can aggregated level intelligence also goes in on that. Self learning onto that piece.
Okay, I'm almost envisioning like a panel inside of Altium Designer. Is that what you're thinking?
That would be the ideal way to do it, because we don't think and we don't believe that it's a right way to have multiple fragmented tools. Rather, if you have a base tool that you always live and work on, intelligence should come within that and almost autonomously, not even like, hey, do something. I'm doing this, I see that there's something suggested out there, rather than somebody manually going and putting in there. So that's our vision, how we want to put it. Yeah.
So like the tool is looking over your shoulder, you're inside a schematic sheet, you click on that voltage regulator, and then right there, oh hey, by the way, this is going to be obsolete. This will be obsolete soon, and here's a suggested functionally equivalent pin for pin alternate.
That's right. I mean, for whatever reason, and then saying, well, there is not just a pin to pin, but because you're building something like this, there is a possibility that you can go to another part which doesn't look exactly the same, but you know what? It will work for you, and there's a reason why. That's what we do today in the system to be able to show them that the scoring is actually going out very well, because the Wizerr score does it almost trade-offs are like an engineer. So we train it, we continuously work on that score. That's highly regarded because that scoring gives them an ability to go beyond drop-ins, right? Drop-ins are hard to find all the time. So can I actually use something? And then we can tap into the supplier systems to say, by the way, do you have a supplier that is, giving this on that? So something like that could be uh, available in within Altium.
This is interesting because what you've just described is what is kind of aligns with my view on how AI is going to play a role in the lives of PCB designers in the future. I think a lot of people have this kind of idea that AI is just going to replace all of us, and that the designers are all going to have to find jobs doing something else. I don't think that's true. I think it's going to be a capability enhancer, and it's going to, I think it'll create bifurcations in financial outcomes, but I think it, by and large, the folks who have the opportunity to improve their workflows and their processes using AI and do it successfully will continue to be highly successful in this field. And it sounds like that's where you're aligning with, right?
And
Yeah.
we call it an AI teammate for a reason, because it is truly a teammate where somebody is sitting with you and saying, hey, I have to do this tedious job of searching through 20 data sheets to find an alternate. Can you go do that for me, kind of a thing, right? Help me with the analysis to do that. And why? Give me a reasoning that why you think it's a good one. And that comes in voila. So I truly believe that engineers will be able to do a lot more, build more products, build some really creative things. And that's what I'm very passionate about. I think hardware world has just started. We haven't even seen what could be done in hardware products, because there were so many problems that we have to deal with to actually get to something really that is in production. Now one can think of creative ideas of great hardware, great products, consumer, whatever it is, and actually build it very soon. So I believe that's going to be a great enhancer for how the world is going to change. We might see very new kind of products coming in the world. That will be a holy grail.
Well, I think this has been such a great discussion, and I'm hoping that all of the folks listening out in the audience are going to be eager to learn more about Wizerr. So if you could tell everyone that's listening or watching on YouTube where they can go to learn more about the company or the product.
Well, the best place to start is Wizerr AI, Wizerr with two R's, Wizerr.ai. And that we share the product knowledge and everything, but definitely ping us anywhere, because we don't share everything. However, we share a lot of education publicly on a forum called OpenELX, which happy to share on that, because this shift is bigger than one company. As I said, it's about the industry now, and I think there are many overlaps where we can come in. So yeah, start with Wizerr AI, Wizerr AI, and also on LinkedIn if we can.
Excellent, excellent.
Yeah.
Well, we'll include some of those links in the video description for folks that are watching on YouTube. Avi, thank you so much for being here today. This is extremely interesting. I'm really excited to see where your platform grows, and I'm hoping more and more designers out there will go and get familiar with the AI tools that are coming online, and hopefully go learn about Wizerr.
Thank you so much. Thanks for having me. I just want to truly feel that AI has already changed software. It's hardware's turn now, and we want to collaborate with as many companies and people as much possible.
I totally agree. Thank you so much. To everyone that's out there listening, we've been talking with Avinash Harsh, co-founder of Wizerr AI. If you're watching on YouTube, make sure to hit the subscribe button. You'll be able to keep up with all of our podcast episodes and tutorials as they come out. And last but not least, don't stop learning, stay on track, and we'll see you next time. Thanks, everybody.